Most reactions that you'll see in organic chemistry can occur by multiple different mechanisms. And mechanisms are the order in which bonds are broken and new bonds are formed over the course of a chemical reaction. We're going to predominantly focus on polar reactions. Polar reactions are those in which when a bond undergoes heterolysis or heterolytic cleavage, both of the electrons stay with one of the species, one of the atoms for whom the bond broke. And this will often result in a negative charge on one species and a positive charge on the other. Another main class of reactions are the the radical reactions, where you get homolysis, where each atom gets one of the electrons in the bonds. So when we make bonds in polar reactions, both of the electrons that will go into forming the bond come from a single one of the atoms. And so oftentimes that means that we're starting with something that's negatively charged, and that's what's donating the electrons to the bond, and that's bonding to something that's positively charged. They won't always be positive and negatively charged, or they won't have a full charge on them, but still one of those species will be the one that's supplying the two electrons to the new bond. And just remember that bond making is always an exothermic process. It always releases energy. And so what that looks like on an energy diagram is that if you have two atoms and they come close together, when they form a bond, they release energy and are now in a potential energy well, and they'll kind of hang out in there. The depth of that well depends on the strength of the interaction. So here it's a pretty strong interaction compared to a much weaker interaction, much weaker bond. In order to get these atoms apart, I do have to put energy into the system to get them away from each other. Okay, so an example of a reaction for which there's at least two mechanisms is nucleophilic substitution. And in one of those mechanisms, the heterolytic step is where bromide leaves. In this example, bromide is leaving and taking its electrons with it, and it's taking the electrons in this bond away from carbon, which leaves carbon without the electrons, and so it ends up being positively charged. And so we call that a carbocation. And we'll look at a carbocation in a couple minutes. So with the heterogenesis, when we form the bond in a polar reaction, both of the electrons that are used to form the bond come from one species, in this case the oxygen of the acetate, and one of those lone pairs are then the electrons that bond to the carbocation to give a new bond. And so there's the new bond. So that's one mechanism for nucleophilic substitution. In another mechanism, both of those steps occur simultaneously, where the negatively charged species attacks and forms a bond to the carbon at the same time that the leaving group leaves. Again, these are both polar reactions. One bond is being broken, one bond is being formed, but the electrons are always moving in pairs. So two electrons from a lone pair of this oxygen, and then two electrons in the bond go with bromine in order to give the bromide product.